Hi class, this is Miss V, your physics teacher. In today's video, we are going to review on capacitors and capacitance. What is a capacitor? What is a capacitance? How are we going to calculate the capacitance of a capacitor? Let's find out. A capacitor is a device that stores electric energy. It is used in many devices like computer motherboards, televisions, and radio circuits, and many others. And the standard symbol for a capacitor is this one. The simplest type of a capacitor consists of two parallel conducting plates, separated from each other by a thin sheet of insulating materials or dielectric. In the neutral state, both plates have an equal number of free electrons. When connected to a source of charge, such as a battery, the positive terminal of the battery removes electrons from the plate connected to it and transfers them to the other plate. As a result of this, the two plates are equally both oppositely charged. Take note, no electrons flow through the dielectric because it's an insulator. How a capacitor stores energy. A capacitor stores energy in the form of an electric field that is established by the opposite charges on the two plates. The ability of a capacitor to store charges is called capacitance. The capacitance of a capacitor is mathematically defined as the ratio of the amount of charge in one plate to the potential difference between the plates. And the formula is like this. C is equals to Q over V, where C is the capacitance, Q denotes the charge, and V denotes the potential difference. So kindly take note that capacitance is always positive. The units of capacitance is coulomb per volt, and coulomb per volt is also equal to farad. So the SI unit of capacitance is the farad, and it is represented by letter F. Now let's move on to parallel plate capacitors. A parallel plate capacitor consists of two parallel conducting plates, each of area separated by a distance. When the capacitor is charged, the plates carry equal amounts of charge. One plate carries positive charge and the other carries a negative charge. The plates are charged by connection to a battery. The capacitance of a parallel plate capacitor is affected by the following factors. First, area of plates. The bigger the area of the plates, the greater is the capacitance. If the plates are large, charges can distribute themselves over the large area, and the amount of charge that can be stored on the plate for a given potential difference increases as the area is increased. So again, the bigger the area of the plates, the greater is the capacitance. The second factor is the distance between the plates. The closer the plates to one another, the greater the capacitance. So the more closer they are, the greater the capacitance. And if there are more distance between the plates, the farther they are, the less is the capacitance. So again, the capacitance is inversely proportional to the distance between the plates. So again, the closer the plates to one another, the greater the capacitance. The last factor is the insulating material or the dielectric between them. If you could still remember, insulators are materials that resist the flow of charges. And as I have mentioned a while ago, that the dielectric or the insulator materials between the two plates resist the flow of charge. No electrons flow through the dielectric because it's an insulator. So the last factor, insulating material or the dielectric. Now these factors are the factors that can affect the capacitance of a parallel plate capacitor. The dependence of the capacitance of a parallel plate capacitor on the factors stated a while ago is mathematically expressed as this. So kindly look at the formula where C is the capacitance, A is the area of one plate in square meters, and D is the distance between the plates in meters. And this Greek letter epsilon, that looks like letter E, is the permittivity of the insulating material or the dielectric. So again, for the parallel plate capacitor, the capacitance of a device depends on the area of the plates and the distance between the plates. And here is the formula, where A again is the area of one of the plates, D is the separation or the distance. The permittivity is a constant. So for this case, it was given that the permittivity used is permittivity of free space. So the constant of permittivity of free space is 8.85 times 10 raised to negative 12 coulomb squared per Newton times meter squared. Now we are going to use the permittivity of free space if the insulating material or the dielectric is not given. Again, if there are no insulating material or dielectric given, or the permittivity is not given, then we're going to use the permittivity of free space, because then again, if there are no material in between the two plates, then it means that there's only free space in between them. So we're going to use the free space or the permittivity of free space. So now, let's try to calculate the capacitance of a capacitor. We have here an example. A parallel plate capacitor has plates 2.00 meters squared in area, separated by a distance of 5.00 millimeter. A potential difference of 10,000 volts is applied across the capacitor. Determine the capacitance and the charge on each plate. So the given was a volt of 10,000 volts, and then the area was given for each plate, it's 2.00 meters squared, and the distance of 5.00 millimeter. Since we are dealing with the parallel plate capacitor, the capacitance can be found as this. The formula, capacitance is equals to the permittivity times the area over the distance. And for our case here, there were no insulator material or dielectric mentioned, meaning to say in between the plates are free space. So using the formula and the permittivity constant of free space, and from the given, let's apply now the values to the formula. So for this case, the permittivity of free space is 8.85 times 10 raised to negative 12 coulomb squared over Newton times meter squared. times the area, which is 2.00 meters squared, over the distance, which is 5.00, times 10 raised to negative 3, again, is milli. The value of milli is times 10 raised to negative 3, and then the meter. Okay, so using your calculator, kindly compute the value of the capacitance. Okay, if you get the same answer, the capacitance is 3.54 times 10 raised to negative 9. Okay, again, the unit is farad, so it is in farad. So it is 3.54 times 10 raised to negative 9 farad. You can also make it shorter by simply writing it as 3.54 nanofarad. So again, times 10 raised to negative 9 is nano. So replaced it with the symbol for nano, N, and then these unit farad. So once the capacitance is known, the charge can be found from the definition of the capacitance via charge and potential difference. So we already had the value for the capacitance, and we are also asked to determine the charge on each plate. Now, using the formula, if you could still remember, the formula of the capacitance is capacitance equals the charge over the potential difference. So using that formula, C is equals to Q over V. We just transform the formula, and then we will get the formula for the charge, which is Q is equals to C times V. Okay, so potential, the capacitance times potential difference. So from the value that we got, the capacitance, 3.54 times 10 raised to negative 9 farad, we will times that to the potential difference in volt. Okay, so times 10,000 volts. So kindly calculate the value using your calculator, and you should get 3.54 times 10 raised to negative 5 coulomb. Okay, so again, we are asked to find the charge, and the unit for charge is coulomb. If you could still remember, again, farad is a unit, and it is also equal to coulomb per volt. So when the volt was cancelled out, we will get the unit for coulomb. So kaya siya naging 3.54 times 10 raised to negative 5 coulomb. Let's have another example. Let's say a capacitor consists of two square metal plates, each measuring 5.00 times 10 raised to negative 2 meter on a side. In between the plates is a sheet of mica measuring 1.00 times 10 raised to negative 4 meter thick. Letter A, we are asked to find what is the capacitance of this capacitor. And for letter B, if the charge in the one of the plate is 2.00 times 10 raised to negative 8 coulomb, what is the potential difference between the plates? So we have here our given. First, so let's analyze first the problem, and then let's write the given. The given here we have is that the two square metals, each measuring 5.00 times 10 raised to negative 2 meter on a side, meaning it is the measurement of the side of a square, which is 5.00 times 10 raised to negative 2 meter. And take note that 10 or raised to negative 2 or times 10 raised to negative 2 is the equivalent value of centi. So meaning to say, we can also write this value as 5.00 centimeters. So times 10 raised to negative 2 is centi, so it is centimeter. Now, take note that it is the measurement of the side of a square. And based on our formula, we need the area of the plates. So in order for us to get the area, so how do we get the area of a square? So we only need to what? What are we going to do in order to get the area of a square? By square the side. Now by raising the side, the value of the length of the side into 2, square mo lang siya, so we can get the area. So again, in getting the area of the square, apply the formula. So side is 5.00 times 10 raised to negative 2 meter, tapos raised to 2, squared lang. Then you will get the area, which is 2.50 times 10 raised to negative 3 meters squared. Another value given was the thickness of mica. So mica here is the insulator used in between the two plates. So the thickness of mica is 1.00 times 10 raised to negative 4 meter. And take note, mica is in between the plates, meaning to say its thickness also serves as the distance between the two plates. So meaning to say, the thickness of mica is also the distance in between the two plates. There are constants or permittivity constants for different types of materials being used as insulator or dielectric. So for our case, mica's permittivity constant is equals to 4.8 times 10 raised to negative 11 coulomb squared over Newton meter squared. So those are the given values from our sample problem. Now let's go to the first part. Letter A. What is the capacitance of this capacitor? So using the formula, capacitance is equals to permittivity times the area over distance. By the given values, no, apply lang yung mga given values to our formula. So we have here the permittivity of mica, which is 4.8 times 10 raised to negative 11 coulomb squared over Newton meter squared, times the area, which is 2.5 times 10 raised to negative 3 meter squared, over the distance, which is 1.00 times 10 raised to negative 4 meter. And of course, canceled out the units that should be canceled, leading us to our final answer for capacitance. Capacitance is equals to 1.20 times 10 raised to negative 9 farad. So kindly calculate using your calculator if you get the same answer. The capacity, or the capacitance rather, is equals to 1.20 times 10 raised to negative 9 farad. Now let's move on to letter B. So in letter B, it is said if the charge in one plate is 2.00 times 10 raised to negative 8, then the potential difference may be computed using the formula. Again, the formula for capacitance. Capacitance is equals to charge over the potential difference. So we're going to use the formula C is equals to Q over V in finding our potential difference, because we are asked to find the potential difference. So using the given charge, again, so given yung charge ng isang plate, which is 2.00 times 10 raised to negative 8. And from letter A, we already computed the capacitance of the capacitor. So we now have the value for capacitance, which is equals to 1.20 times 10 raised to negative 9 farad. Now, Using the formula, capacitance equals the charge over the potential difference. Transform the formula, so it will be potential difference is equals to charge over the capacitance. Okay, so just formula transformation, it would be V is equals to Q over C. Now, applying the given values that we had, we can now compute the potential difference. Now, V is equals to 2.00 times 10 raised to negative 8 coulomb over 1.20 times 10 raised to negative 9 farad. Now, paano makakancel yung units? Take note that farad is again equals to coulombs per volt. So, si coulomb ay makakancel out, leaving us the unit volts. Now, the final answer for this, kindly calculate using your calculators. It should be V is equals to 16.7 volts. So, to get the final answer, it should be 16.7 volts.